All right, so for page 42, Graphing Inequalities Part 1. So inequalities can be written in one of the following 5 forms, are called linear inequalities in 2 variables. So go ahead and underline that. So linear inequalities. So instead of an equal sign, we're given an inequality sign. So remember, we have greater than, less than, greater than or equal to, less than or equal to. So we're going to label all of those different symbols. So this symbol right here, this is the greater than symbol. So we're just going to label each one of the symbols, each of the inequalities. So this is greater than. This one is the opposite. It's going in the opposite direction, which means it's less than. So we're just labeling the different inequality symbols. The next one with the little line underneath of it, it's greater than or equal to. So anytime there's a little line underneath of it, you add a little or equal to. And same thing for the last one, except less than or equal to, since it's in the opposite direction. So those are our 4 different symbols. Greater than, less than, greater than or equal to, or less than or equal to. All right, so now we know the 4 different types of inequalities. So here A, B, and C are real numbers, and A and B are both not 0. A solution of an inequality in 2 variables is an ordered pair that makes the inequality true. You can represent solutions of an inequality with a graph and manipulate inequalities much like you manipulate equations. So we're going to complete this table to show whether the given points satisfy the inequality or not. So our equation, I'm going to highlight our inequality that we start with. So we start off with 2x plus 3y is less than or equal to 12. And we're going to figure out if any of these points are or are not solutions to that inequality. So this first number, that number represents our x value of the coordinate. The second number represents the y value of the coordinate. So everywhere there's an x in my inequality, I'm going to put the number -1. And anywhere there's a y in the inequality, I'm going to put the number 6.5. So I substitute the number -1 into the first and 6.5 into the second. So now we just calculate some of these answers. So 2 times -1 is -2. And then I have 3 times 6.5, which I can do that in the calculator. So 3 times 6.5 is 19.5. So I have -2 plus 19.5. And I want to know, is that less than or equal to 12? Because if it is, it's true. If it's not, it's false. So now I just need to calculate that. -2 plus 19.5, that's equal to 17.5. So this is saying 17.5 is less than or equal to 12. Is 17 less than 12? No, 17 is bigger than 12, so this is not true. This is false because 17 is not less than 12, which means it is not a solution. A solution is only when it's a true statement. So no, it is not a solution. And we're going to go through each one of the coordinates, figure out if it's true or false. If it's a solution, it'll be true. If it's not a solution, it'll be false. All right, so looking at part B. So the 0 is my x, the 3 is my y. So everywhere I have a 0 in my inequality, I put the 0 for x, and anywhere I have a y in my inequality, I put the 3 for y. So 2 times 0 is 0. 3 times 3 is 9. And I want to know if that is less than or equal to 12. So 0 plus 9 is 9. And then is that less than or equal to 12? It's less than 12, so that makes it true. Since it's one of the two, it's either less than or equal to 12. So it's true, which anytime we get a true statement, yes, it is a solution. All right, so we're going to go ahead and look at the coordinate for part C. So the x is 4, the y is 2, so we'll substitute the 4 in for the x first, the 2 in for the y second. So now I'm going to calculate 2 times 4, which is 8, and then 3 times 2, which is 6. So 8 plus 6, is that less than or equal to 12? 8 plus 6 is 14. Is 14 less than or equal to 12? It's not either of those, right? It's not less than 12. It's not equal to 12. So this one is a false statement. It is not a solution. We're going to do that for each one of the coordinates. So the first number is your x, the second number is your y. So we'll do 2 times 6, which is 12, 3 times 4, which is also 12. So is 12 plus 12 less than or equal to 12? Well, 12 plus 12 is 24. Is 24 less than or equal to 12? Is 24 less than 12? No, it's greater than. So this is a false. False means no, it's not a solution. So we've got more coordinates that we're going to check, and we're going to do this kind of quickly. First number is your x, second number is your y. So we'll put -2 in for x, -1 in for y. And I'll show you how we can type this into the calculator. So we'll do 2 times -2. So 2 parentheses -2 plus, and then we have 3 times -1. So that's equal to -7. So is -7 less than or equal to 12? Is it either of them? It is less than 12. It's smaller than 12. So this one is a true, which means yes, it is a solution. And for each of these, I'm going to type into the calculator. So the first number is -1, that's my x. The second number is 2, that's my y. So I'll do 2 times -1, and then 3 times 2. I can put that into the calculator to save myself a step. So that gives me 8. So this says that 8 is less than or equal to 12. Is that true or false? Is 8 less than or equal to 12? It's less than 12, so that makes it true as long as it's one or the other, which anytime it's true, that means yes, it is a solution. So this time we'll plug in 1.5 for x and -2.5 for y. And especially when we have these decimals, we want to use Desmos to help us do the math. So 2 times 1.5 and 3 times -2.5. That gives us -4.5. Is -4.5 less than or equal to 12? It is less than, which makes it true. So yes, that point is a solution. And we've got one more coordinate to check. So the x will be 5, the y will be 0. So 2 times 5, 3 times 0. This one I can actually do in my head. 2 times 5 is 10. 3 plus 0, or 3 times 0 is 0. So is 10 less than or equal to 12? It's less than 12, so that makes it true. And yes, this is a solution. So there's a couple more things that we need to list out at the bottom. So anytime I give you a line, okay, so I want to graph this inequality. So this was 2x plus 3y is less than or equal to 12. So we see this. So anytime we have a solid line like that, any point that's on this solid line is a solution. Any point that's in this shaded region is also a solution to our inequality. And we're going to just make note of that down here at the bottom. So if a point is on the solid line, so we have two different lines, solid lines and dashed lines. So if our point is on a solid line, thank you, then it is a solution. If it's on a dashed line, it is not a solution. And if it's in the shaded region, that's another time when it is a solution. So if the point is in the shaded region, it is a solution. So that's something also worth noting. If the point is in the shaded region, it is the solution. If the point is not in the shaded region, it is not a solution. So those are the last two notes that we need to take on page 42.